since some people were interested, and in fact, Carol mentioned in the last part of her talk about mathematics and geometry, it's better to actually start from the word mathematics, because this is what we call it, mathematical structure, mathematics and art. And what is mathematics? Where this word has come from? Actually, it is interesting to know that the person who coined this word mathematics is Pythagoras or Pythagoras. Somehow, actually, what's the meaning of mathematics or mathematica? Actually, I should mention that Pythagoras, we call it a kind of Greek philosopher and mathematician. By Greek, immediately we feel a country in West. This is what some Western scholars tried to do many, many centuries, in a way that we feel that there is something as a kind of knowledge in West, and there is another type of knowledge not as important as West in East, which is totally wrong. Pythagoras, actually, or Pythagoras, was born here in Turkey. So we should call him a Turkish mathematician, not Greek, if we are going to actually talk about the land. If we want to talk about the humankind and human understanding, Pythagoras is everybody's person, does not belong to a specific land. In fact, that was the case. He was born in Samos, which is a city now in Turkey, and he went to a city in south part of Italy. So he never met, he was never in the land that we call today Greece. Anyway, so Pythagoras actually coined the word mathematics, which means everything that we know. In fact, he divided mathematics into four disciplines of arithmetic, geometry, astronomy, and music. So for Pythagoras, music was mathematics. In fact, the scale of music now today is used in West, which has 7 notes, was originally created by Pythagoras. Actually, Pythagoras and Pythagoreans believed in numbers. Actually, his followers, many, many years later, Sanai and others, as Carol mentioned, believed in numbers. And then he used numbers 1, 2, 3, 4, that the sum become 10. And then 1 over 2 is 1/2, 2 over 3, and 3 over 4. Then he made a system of music that 1 to 1/2 is 1 octave, and 2/3 and 3/4 are 4th and 5th note, sol and fa. And then he used this division to make 7 notes. And then these 7 notes was the system of music for many centuries, up to 16. And in 16th century, because then they actually they made big organs, they needed to have a kind of a system that actually be equidistant. They actually made it a kind of equal temperament that we use it today based on 12 root of 2. This is the division that Farabi actually made based on Pythagoras. Actually, he believed in Pythagoras as mathematics, 4 pieces of hendese, hesab, nujum, musiqi. Let me put it in English, sorry. Okay, in arithmetic, geometry, music, and astronomy. But he added 3 more, mechanic, measurement, and optics. In fact, what Carol said about the type of mathematics that we have, some mathematics for scholars and some mathematics for people for buying merchandise and things like that. We should give credit again to Pythagoreans. They believe that mathematics is mathematics of people who are in the business, and then mathematics that is appreciated as something that we use for more sophisticated job. However, Farabi adds that measurement here, that is measurement, that is the mathematics that people in business should use. And then optics. Optics become very, very important and a kind of big issue. In fact, that is that we should give credit to Islamic scholars that they talked about optics and how actually we receive light, how we can see objects, that this is when the light actually go to the object and comes to our eyes. This changed totally the understanding of how to see object from the Greek belief that they believe that something from our eyes go to the object. Actually, that was the beginning of projective geometry that actually flourished and actually become more important during Renaissance time. So what is Hendese, geometry? Where this word has come from, why we should say geometry for what we think, which has the same meaning for Hendese. Actually, the geometry, again, is another Greek word, has two parts, geo and metrian. Geo means earth, and metrian means measurement. In fact, Herodot believes that the word has come from the action of measuring land of Nile River, the bank of Nile River, that goes back even 1,500 or maybe 2,000 years before even Pythagoras was born, because those structures that you see in Egypt of those pyramids and actually shows a very, very sophisticated mathematics showing that there was a system that actually that people had to pay tax based on the land that they had by the Nile River. So for the measurement of those lands, there were some people, or the first mohandes, or the first mohandesin, or the first mathematician or geometers, were the people who used to actually measure these lands and based on that ask people to pay for tax. So then the lands happen to be like different shape, rectangle, square, and triangle. So what these mathematicians used to do was to, based on the shape, find the area and then give report. So then through these booklets or these documents that we have from many years before even the mathematics become established idea in Greece, we had this in Egypt. So the word has come from that activity. However, what happened, why we give lots of credit to mathematicians or to in Greece is they started establishing a system of philosophy, and through that philosophy they tried also to establish a system, the same type of system for philosophy for mathematics, based on deductive reasoning, based on argument, based on axiomatic system. So that is what actually we say that Thales was the father of mathematics or pure mathematics. And then Pythagoras was the one who actually popularized this mathematics, and then we can call him correctly the father of mathematics as we understand today. And of course, geometry. Okay, so this brings us, so that was the kind of the first part that I wanted to mention. And let me actually, again, that is a part of my talk for yesterday, that in general, we have three different ways of tiling a surface if we want to use regular polygons. These are like triangles, squares, and hexagons. And in fact, since triangles and hexagons are, they are dual of each other, if we know how to do hexagons, we know how to do triangles, these two become very important for covering a surface. So this has happened that, like, we have many, many different type of tiles that has, like, this frame, square or hexagon. So this is one tessellation of a star based on square. And with the same type of a star, we can do the same job of tiling a surface, but now we are using hexagon. In fact, if we are not very familiar with the structure, we may take a look at these two and we feel that they are the same. They are not. One of them is based on square, the other is based on hexagon. So this is like, for example, if I show you, you say that this is based on a square, and you are right, this is based on hexagon, this is based on a square, and this is based off hexagon, this is a square, hexagon, oops, and what is that? This is the one that we don't know. It is not a square, it is not hexagon. So this becomes like the point of interest of many mathematicians, many artists, craftsmen, to actually, when they see such a structure, understand how the layout of this pattern has happened. That is what we call it gere, and that is become more complicated because it doesn't go through the same rule as square or hexagon and so on. And the same is true. You have seen this by now many times of marage and also the pattern, which is the same pattern on that part of structure that I showed you. Now, going back to this, actually, I would like to actually, if you take a look at the tile that also has a flower inside of it, which is the same tile as all over, but without that flower. So that flower is not important, it's only for the beauty. If we take a look at that one as one tile, I would like to concentrate to that tile. Actually, it's a traditional name in Persian architecture. They call that one table. And so I would like to actually tell you how to make a table very easily. Okay, if you have a regular pentagon, if you rotate another regular pentagon like 36 degrees, and then if you clean up some of those intersections, you end up to this, I call it decagram shape. So with the same idea, if you want to do it for a square, this is what I did it for two pentagons. Pentagon, another pentagon, and then, okay, if I want to do it the same idea for two squares, this is very common pattern in Islamic art. When you do it that way, you can actually clean it, and then here you go, you have it. So this I can call this one octagram. Okay, if I have like this is one pattern based on octagram. When you make octagram design based on two squares that they rotate inside each other, you see that you have octagram, and in between you have another shape. So this tessellation has two shapes, octagram and something that you see which is a cross inside. So we can call this one cross octagram pattern. So this is one tiling in Arg Karim Khani in Shiraz, Iran. And as you can see, one tile includes octagram and a quarter of that cross. When we put next to each other, we see both. We see octagram and we see cross. Now, if you go to this museum, archaeological museum of Istanbul, which is not very far from here. And then you see another type of tiling. You see that now we have separated cross and octagram. When we put together, we get the same pattern. But now we have octagram and cross, each separately as module. So we put this together to get the same pattern. So in this tiling, rather using one tile of octagram and 4 quarters of cross, we have 2 different modules, so we can put this together to make it a pattern. So here, I'm going to show you here. There you see that if we create everything in one tile put together, or we create 2 different tiles to put together, we get the same result, the same tiling. This is difficult for octagram, for this decagram. We cannot do the same easy job of making it in square and then copy it, and then we hope that we get something more meaningful in design. We may try to do something inside, as you can see, but when we want to talk about doing it outside, we have more thing to do. So let me first start making one of those patterns using decagram. This is based on the method that I was talking yesterday, and I'm doing it again. It's based on 10.3. So, and then the extension of some of those lines. And here you go. I come up with the unit that I can use in order to make this tessellation. If you look at this tiling that I used, using that one circle and then division of it, and then finally come up with the pattern, inside you see decagram and many other objects here. They have, I know Iranian name for all those pieces. I will call them, but like for example, that bow is sormedan. Those pentagon, we call it panch. I think also is like a kind of Turkish word. And then panch. Yeah, that was what I said, panch.
That's Indo-European.
Yeah, Indo-European. So that's why everybody say panch. Good. So pentagon is panch. Okay. And then we have panch and torange. Torange is the one that has like yellow color, has 4 sides. And did I call all of them? And okay, so I have all of them in my presentation. Anyway, this is one of the patterns that actually is based on this tessellation, exactly this tessellation. And now if I want to compare these two, look at here. This is a tiling that is using all these 5 objects that from left is torange, panch, sheshband, sormedan, table. Actually, look at this tessellation and look at that tessellation. Both these tessellations are using these 5 objects. Are they the same tiling? No, they are not. Why? Because look at the location of these tables. Look at there, look at there. This is a farther distance. They're closer. And then look at sormedan. Is like a little bit moved slant, but there is like horizontal. So these 2 tilings, even though have the same ingredient, the result is different. This tiling is different from that tiling. So now let's go and find more methods to make more those type of tilings and then compare with this tiling if they are the same. Okay, what I did, after searching in Maher al-Naqsh book of execution of design in Persian mosaics, and I found one of those structures. So I'm going to present here. So I have a right angle, and divided by 5, and then consider a point, arbitrary point as C there, and then do a kind of routine work. Actually, if you do it, a few of those constructions, you learn how to do it. And then, because when you divide an angle to 5, definitely you are thinking about decagram as a part of your work. Okay, so this is that tessellation. Now look at this tessellation. Beautiful. Again, we have decagram, table, we have sheshband, we have panj, we have sormedan, and toranj. So we have all these 5. So what we do, we put that, and this is one tessellation, which is exactly like that. Imamzadeh Darb Islam, Isfahan. Another one, Masjid Said, Isfahan in Iran. Now consider this one and put it, we did it for this one, we put it now next to this tiling. Are they the same tiling? No, they are not. Again, look at there. The position of tabs are totally different from that. Here, you know, they are vertically and horizontally in line. But, and then there is a, when you look at there, you have a kind of diagonal row of decagrams. So these two, even though have the same 5, I call them saze. Saze meaning those, saze tile means those that we use in order to construct the pattern. So even though both have used the same saze tile, they are different from each other. So this is a unit for, actually, it is not fundamental region. Fundamental region should be a quarter of this. But I can say that this is a unit to generate this tiling, and that is another unit to generate that tiling. And none of them are the same as the tiling that I showed you. Okay, so let me, in fact, this brings us to be more classified about the use of this type of methods. Actually, after my studying, I found 3 different methods that we use somehow compass and a straight edge in order to achieve construction. One is the radial grid method. That is the method that I just did it, used for construction of that decagram pattern. This is the image from that interlock treatise that was appended to the Buzjani's work. So based on that, actually, not exactly, because this is 12. So I used this method, radial grid method, to actually create a kind of star interlocking pattern. So again, I divided this into 5 and then used the method presented there. So this A, B, C, D, E, F, G, H, and these letters, if you follow in order, it shows you how that can be constructed. This is what I did it. So after each action, I labeled it. So the same radials that go from there, I rotated and put it this way. And okay, that is that famous structure, has tenfold, and all over has stars, as you can see. And this is very famous. You have seen it in many, many constructions. So this is one way of producing this structure using the method of radial grid. Now, I'll show you another method that Jay Bonner actually, in fact, talked about it. Hanken, that the guy who actually was in India and actually noticed and wrote a paper about that. And now, in this method, actually, we consider 3 blocks. And these 3 blocks can be used in order to generate the underlying pattern for us, like that. Then, in order to come up with that star pattern, that I showed you, I pick the midpoint of each of those segments and connect using my straight edge, and then erase the lines behind the blue ones. I come with the same pattern, the same star patterns that we did in the also in the previous method. I should say that also, in addition to Jay Bonner, Peter Cromwell, who's here, he has written a paper, good paper about that. What was the title of the paper, Peter? That you mentioned about Hanken method and actually presented very beautifully a few, several of them, yes. One of them was the first one that you did for Journal of Mathematics and Art. Forget about it. Okay. So, but he has some papers. He's here, so you can talk to him about that. Okay, and then this is a method that actually El Said did it in his book and about Aisha Parman. And perhaps you have seen it. It is in the library here. So this is based on, again, using division of, like making a star polygon and then extending the segments. And finally come up with exactly the same star polygon. So here I showed you 3 different ways of generating this. And I can say that definitely for one of them, or at least for 2 of them, we have good documents. For El Said, we don't have document to show that it has been used by people in the past. Definitely has been used. But for the other 2, at least we have one. For the other one, for this, actually, we have that paper by Henken. And then for the other one, we have a good document from 13th century appendant to Buzjani's book that actually that shows how we can use radial grid method in order to generate them. Anyway, so now I actually do use the same radial method to generate this tiling. As you can see in this tiling, again, we have the same element that we have decagram, table, sormedan, sheshband, all of them are the same. And then I would like to show you that also that can be done using the method that was introduced by El Said. They're identical. And then if we want to put it next to this structure, see whether they have the same pattern as the other ones. If you compare, again, you see that this is not that one. So this is not none of the above. This actually encourages us to think about a little bit more seriously to find a way to analyze such an image. So far what I have done and those structures that I made for you only follows 2 rectangles. And none of them are squares. Because if I want to divide it based on a square, I have problem because the arbitrary point that I should pick in any of those radials that divide the angle into 5 is not just in the middle. So I should actually modify this method a little in order to be able to use this radial method to create that pattern. So now look at this structure, and I'm finding the line of reflection. This half is the same as the other half. And then this is repeating also. This part is reflected to the other part. Oh, good, 10 minutes. I thought that I'm done. Okay, so I can do that. And then I find a region for myself as a fundamental region that if I can construct that piece, I can actually use reflection to create the entire work. So I concentrate on this piece and try to actually use radial method to generate this piece. So this is like a kind of workshop type and give you idea how a person can go step by step to create one of these designs using radial method. So this is what I did. Rather picking up a point in the middle, I started with radius of a circle. And then after that, I followed the same idea. It is very difficult really to write down step by step what I've done. But I did it slowly and then discovered that these lines should follow that pattern. And after a while, I came up with the pattern, which is exactly the same as this. So I was so happy that did it as a kind of work of art and put together. So, so these four, as you can see, have four fundamental regions, should I call it, actually that create the tessellation are different from each other. But how many different ways we can do it? This is a good question. Perhaps this has come to the mind of people in the past that, okay, if I can do four of those, how many different ways I can use like tiling using these 5 tiles? Using these five Saze tile. Here, I need to quickly talk about a modularity approach. I will talk about this specific modularity approach in my workshop a few days from here. But let me show you, like this is a picture from a market in Morocco showing you that really they make those tiles separately and they are ready only to find the pattern. If the pattern matches, they start putting those. So I can call this Saze tiles that are ready to be installed. That is the traditional way that has been done in Persia, in all other cultures, in Turkey and so on. So I bring you to this pattern that actually was presented yesterday and today, which is in Topkapi scroll, and we talked enough about that. And the discovery of these 5 units as a tool, like playing a game. Look at this one. These 5 definitely, actually, that can be found in this Topkapi scroll if you follow those dashed lines, if you separate them and forget about those strong black and red colors, you will come up with these 5. And then these 5 actually will help you in order to come up with the same pattern over and over. Actually, such a system actually is not one-time shot. Actually, I should give credit to many people from Emil and where is Emil here? Oh, it's there. Yes, he wrote a paper about that many years ago. That was the first paper that he wrote about Morocco. Which year was that? 92. So that was, and then many people here in this room contributed, and Jay, his paper appeared in 2003 that he referred to the same system. Jay, are you here? Oh, Jay's there, Jay Bonner, yes. And then the person who is not here, Peter Liu, was the last person. Actually, this is a kind of, I should say that, humankind effort. We should give credit to humankind, to the brain of people who think and come together and work. And I'm glad that 2007 paper showed in Science, because all of a sudden, it was the kind of issue presented by many people, but all of a sudden, that Science paper brought this to the attention of the world. So I keep receiving from those days, I kept receiving emails from people that I didn't expect, from many, many different cultures and all, that saying that, wow, quasi-crystal patterns have been seen in Islamic art. How come? Oh my God, this is very interesting. And that is good. Consider this as a kind of positive effort that actually brought to the attention of everybody. And so anyway, I'm showing you that those 4 patterns that I made can be easily done if you have these 5 toys to put together to come up with this design. And moreover, you can actually do much, much more. You can look at this very complicated pattern. You can easily put those tiles together to come up with the pattern. He said 10 minutes. Is my 10 minutes over? I don't know. Yes or no? Not yet? Okay, I continue. So now, if you are now interested, I've become more interested in somehow become more, do some more complicated job, rather doing a kind of infinite plane. Why not if I pick up a surface, specific surface, and try to decorate using those 5 tiles? One is like itself, the decagram itself, that actually, you see this is an actual tile done. And here, using those 5 tiles, I'm successful. But we should have a rule. The rule is, in the center, we should always have a decagram, and all vertices should be actually located in a decagram, and everything should be based on a rule, and should have 10-fold rotational symmetry. So then I used this method to create another one. This is another one. And then become interested in to cover a surface of pentagram. And I was successful in order to find ways to use those toys in order to cover the surface of pentagrams in many, many different ways. All of them had. Okay, I stop here because if I want to continue, it will be another subject. I go to quasi-crystal pattern and so on. This will be another lecture, hopefully next year. See you next year. Okay. Thank you. Thank you very much.